Hello, I am Krunal Chauhan from Nvis Technology. Today we are going to talk about the process control. Process control is a very interesting topic. You find this topic mainly in industry, but the thing is that whenever we do some cooking or any process, we do the process control thing, because to even to prepare your dish you need some water into that, you have to cook for some time, you have to maintain some temperature of that. So if everything is right, your process is right, and your output comes very good, your food will be good in that case. Similarly in industry, whether it is a food industry, any process industry for any automobile, for chemical, a sugar factory, whether it is a type of paint industry. So for them process control at a proper level is very important. To control any process we need some controllers. So there are 2-point or 3-point controllers are there. 2-point is nothing but your on-off controller, and 3-point is nothing but your PID controller, proportional, integral and derivative controllers are required in that. So the term is open loop and closed loop first of all. So in open loop you have to do everything manually, like you do your cooking at your home. But if you want to go automatically, then you have to go for the closed loop. Closed loop is nothing but your feedback has to be proper from your sensors, and then you have to decide, you have to analyze according to your past experience or whatever will come into your future, that you have to decide. For that we use a controller called PID controller. Okay, so process controlling can be done for temperature, for your liquid control, for pressure control, or maybe your flow control. So for this we need a process control required to maintain your stability of your system. So for that I would like to show you one product to understand this concept of process control. Nvis Technology is having one product which is Nvis 3002A advanced process control. In this product we are going to see about the liquid level control and your temperature control. So two parameters we are going to monitor in this, and we are going to study how we are going to control it about in this product. Nvis 3002A advanced process control. As you see, it's a very strong product, very heavy product. It's having a complete bench into it. This is your control panel will remain over here. There is a foldable stand for your placing your laptop over here. This product comes in a two form, one with your DAQ card and another one with your PLC. So it's our choice which one we want. Today I am going to show you with the DAQ card how it operates in this case. So there is a drawer in it. So to put your accessories over here, sump tank, it is a 30-liter sump tank has given into it. There is a submersible pump is there with it. Your measuring tank, which is your 15-liter tank, is given in on this. There is one heater which is installed in this tank. There is one level sensor, one thermocouple and one RTD sensors are placed over there. Also one stirrer is given to maintain the temperature of your complete water which is present in that tank. So that is given over there. So this all sensors data we can monitor through the DAQ card, and we can control heater, your solenoid valves, your stirrer from this DAQ card, that we can control it from here. So if I open this control panel, so here you will find the DAQ card from the Nvis Technology itself. This DAQ card works on the Ethernet. So you can place this instrument anywhere in your lab, and you can operate it from anywhere from your campus, so that you can monitor it as well, and you can control it as well from anywhere by using the Ethernet in your local LAN if you configure it on that. So there are 8 number of inputs, 8 number of digital output, 8 analog input, 2 analog output, and the TX-RX pin for UART. So that if you want, you can configure it in RS485 mode as well, is given on this. Here are some switches to control this instrument manually. If you want to start the process, you can click on start. Stop button is there. To control your pump on and off, that we can do. Heater we can control, steerer, solenoid valve, and emergency stop is given, so that in any case if any emergency is there, we can stop it, so whole instrument will get stopped from that. There is one industrial PID controller is given. It looks small, but to configure it, some tricky configurations are there in this. So normally you will find this PID control in industry. We have given in this because if you want to find out how to configure this PID controller by using these 3 simple switches, that we can show to our student that how to use these 3 switches and how to configure this PID controller. There is one temperature transmitter is there, output indicators are given, current, how much your heater is taking current, that you can monitor from this analog ammeter. Over here one process is shown over here, what exactly this process is. If you want to measure your output of your RTD or your level sensor or your thermocouple, so some points are given over here. Here you can place your multimeter and you can measure it manually as well. This Ethernet cable can be connected to your laptop over here. So there is one software in it that you can see over here. This process has been shown over here. You can make this software, you can operate this instrument manually, or if you want to use on-off controller, that you can configure in this. If you want to configure your PID controller for your temperature and for your level, that can be configured in this software itself. So if I want to see the graph of temperature, that I can see. If I want to see the graph of level, that I can see over here, I'll just click on start button. So this graph will start moving. What exactly the water level is there in the percentage, it will show to us. If I want to start the pump, I can click on the pump. So this water will start flowing into it, and I can stop it. If I want to configure the heater, then there is one condition we have given, that your water must be 35% higher in your tank, so that your heater should not burn out without your water. So that condition has been given into it. I can start and stop this process, and I can click manually also from the button. If I click on, that pump has started and some water is going to flow in that. So your level of water level will going to increase it. I can stop it. If I want to start my PID controller, then I must go into the setting, and then I can start the PID controller in that. Like if I want to do the process control for PID, then I should select closed loop, PID, and then PID1. Right now I'm just keeping this KP and KID any value to show you the demonstration, but we can calculate this KP KID value and then we can put it over here, and how fast we can reach to the set point, that we can configure it. So once you have done your setting, you just have to start your PID and click on the start process. So if you want to change your set point, that you can vary from here. Right now it is 50%. So now process has started. Your level is right now 46 something. So pump has on and it is trying to remove the error. So it is going on and off that pump and trying to maintain the water level into it upon 50%. Once it has reached this, the graph of that, we can see in level that how is going to achieve your set point of your liquid level in this. So that can be seen. Even if you go on the manual mode, you can operate this switch manually from here. If you want to switch on or switch off manually, if you want to switch on your heater, then you can switch on your heater. You can switch it off. You can switch on your steerer, or if you want to drain your water, you can switch on your drain valve as well. You can off it, and I have switched off this pump as well. But as I am doing manually, and right now I have configured it in PID mode, so that disturbance has occurred and it has generated some error. So it is going to take it automatically. It has started once again the pump, and it is trying to once again reach to the set point. So to conclude, there is a lot of things to be learned from this product. Liquid level and temperature control. We can use both the process at the same time, and we can configure that PID controller for both the process. That can be done. Even the signals which are coming from your sensors, that you can record into it, that database you can maintain. And if you want to see what we have done in the last experiment, that you can also see on which date you have done this, at what time you have did your experiment. You can take printout of this graph. You can use this graph in your file. You can put it over there. And all the sensors which are used over here are the industrial sensors. So once you will go with this product, you will clearly understand what is required in the industry and how you are going to maintain that process in your industry. So thank you.